All right. So as you've already noticed, third period is the class that I'm going to go ahead and record for all my pre-calc classes. That's why I've got the headset on. I'll always check that. Okay. Sometimes I may get started too quickly and forget about it, so help me remember. But the one thing I do want to go ahead and start out with today is just emphasize a couple of things. One being the website. So especially for the two new gentlemen we have in class, here's our Google website. And well, I've got the code up on the board. Let me go ahead and display this a little larger. ZFT7V94. That'll give you access to this particular website. In fact, how many people have had the opportunity to take a look at the website? Okay, a few folks, yes. Especially if you're absent. That's why I created the website, to help you stay caught up, see exactly what it is we're going to be doing. I'm going to be posting these videos here. It's not quite the same as sitting in class, but at least you're going to have something you can follow along with. Okay, and if you didn't get that, that's fine. I've got it up here on the board, as I said. Okay, if you didn't get that copied, but I do want to go ahead and point out a couple of things. Remember, I do this by the week, so it's usually about mid to later in the week that I'll have the next week taken care of. So expect it, to be a couple of days before you see next week. And here's a listing of everything that's going to be happening this week, all the important details. In fact, number one, you're going to have a language of functions quiz on when? Thursday, the 22nd. So this Thursday, the material we start today, you're going to have a quiz on that. Hello. Okay. We're going to have a quiz on that. It says here we're going to begin focus activities this week. In fact, I'm going to start that tomorrow. I'll talk more about that then. In fact, you'll notice number 3 is a big one. What's number 3 say? For those who can read it, I know it's kind of small. There's an exam, your first exam of the year, an official exam coming up next Thursday, the 29th. So everything we talk about starting today through Thursday of next week, completely fair game for that exam. Okay, so I always recommend, don't wait until the night before to do a cram session, because you're really not learning the material. Kind of review yourself slowly, like maybe in the next night or so, take 5 minutes, if that, review one topic. If you feel good about it, okay, move on. If not, come in for tutorials. Let me help you out with that. Let's see here. What's happening Friday morning by 8:05 a.m.? The exit ticket what? The retake. There we go. So if anybody from last week, that Thursday activity we did, scored below an 80, I've had several people come in and retake. You still have the opportunity to do that. You have several days. But once 8:05 hits, that window's closed. Okay, and the same thing for this quiz coming up on Thursday. You'll have through next Friday morning to go ahead and get that retake done. All right. Any questions on the website? Okay, so remember, if you are absent, absolutely good resource for you. Okay. Now, because we are officially starting, this is the first lesson of the year. A lot of the material at the beginning is going to be review. This is when all the cell phones need to go up. They cannot be on your desk, earbuds pulled out of your ears. We're going to start all those policies, please. I just don't want them to be a distraction, that temptation. Did anybody, I do not see any in the shoe caddy, and that's fine. Okay, but you're telling me you're responsible enough to not pull that out. Okay, so please make sure. Now, I understand it's going to go off. Emergencies happen. Remember, we talked about that. What can you do? Talk to me. Okay, if something's come up, just talk to me. Okay. All right. Well, let's go ahead and get to it. So we have a little bit of review vocabulary before we get into our main topic today, which is going to be sets. So first off, a relation is any set of ordered pairs of numbers. And here is an example of an ordered pair, a coordinate, a location. So basically, any graph that you've ever come across is a relation, because it's a comparison of all the elements in the domain, your x's, and all the elements in the range, your y's. Now, it may or may not be a function. That's something different. Now, here's some vocabulary words that you probably don't know: abscissa and ordinate. So an abscissa is the first coordinate of an ordered pair. What do you think that's referring to? It's the x value. We're talking about an element in your domain. We can also call those abscissas. Or ordinate is going to be the second coordinate of an ordered pair. So those are elements in your range. So we're talking about the y values. Yes. Now, a function, a relation such that no abscissa, the x value, is used more than once. So basically, you were probably taught that it's a function if no value of x, and what's the key word? Repeats. That's exactly right. And one way to do this visually was your vertical line test. Or some of your teachers may have called it the finger test or your pencil test, where you go ahead and slide your pencil left and right across the graph. What are you looking for to tell if it's a function or not? How would we know it's not a function? Okay, so that vertical line is going to touch the graph in 2 or more places at any given time. Visually, that's telling you that values of x repeat. If it doesn't touch it in 2 or more places at any time, well, then it's going to be a function. And we're going to be looking at that in the next lesson, okay? But an interval, this is the one I want to look at here. A set of all real numbers between any 2 reals, or a real value and a positive or negative infinity. It may or may not include the ending real values. So this is probably what you used a lot in Algebra 1, maybe even in Algebra 2, but hopefully your teachers had you start writing your answers in what I'm about to show you. It's called interval notation. Anybody know what I'm referring to? Like, what 2 symbols does interval notation use? Brackets and parentheses, exactly right. Okay, now there is a difference between the 2. So let's go ahead and write out this first one, and then we'll go ahead and kind of talk about it. So I'm thinking about my solution set, all my answers that are x greater than or equal to 5. Okay, so can I include 5 in that answer? 5 can be included, so anything larger than 5, even a decimal value, would be okay. So when you're writing in interval notation, you always go from the smaller to the greater. You always go left to right. And you separate those items using a comma. So what is the smallest element that belongs to this set? 5. So I'm going to start it with a 5. Now, how much greater than 5 can we go? Infinity. Okay, there's no upward bound. All right. Now, here's where we have to decide parentheses, brackets. What do you guys think?
Brackets.
Okay, so bracket and then infinity. Now, infinity is an idea. It doesn't represent a specific number. So no matter what the inequality says, if you're using a positive or negative infinity, always a parentheses. But what's the bracket tell me? That 5 is an element of that set. It is one of my answers. Okay. Now, if I were to compare that to simply x greater than 5, well, I'm going to have virtually the same expression, but I'm going to put a parentheses on that 5. Okay, so let me know that we're starting at 5, but that's not included in the set. I can get really, really super close. I could probably say something like 5.01. That would be perfectly fine, as long as it's not 5 itself. Okay, and then we have this other one here, a compound inequality. So all values of x greater than -2, but less than or equal to 7. Okay, so how would I write this in interval notation? Okay, so parentheses are a bracket. Parentheses, because the -2 is not included, and that is the smallest value, comma, 7, and then what? Bracket. Okay. So these expressions that we just wrote, they are telling us the exact same information as what you used way back in Algebra 1. Okay, that's how we want to go ahead and start writing our answers. We want to really become familiar with interval notation. Any questions on that? Easy? Super. Okay. Well, let's move on to the main idea. Let's talk about sets. Well, a set is a collection of things. I mean, it really could be anything, any data that either you or somebody else has collected. Typically for us, we might be talking about numerical values or even variables, something like that. Okay. Now, there are 2 main ways of looking at it, what we call the intersection and the union. So a lot of symbols are what we're going to be looking at today. A capital upside down U, that tells you you want to take the intersection of 2 sets, the set of common elements from the 2. So what element is in this set and in this set as well? You see how I said that? I used the word and. Verbally, when you're describing these sets, and always tells me we're going to take the intersection. Okay. Now, instead of an upside down capital U, you can also use a capital upside down V. That's a perfectly acceptable symbol. Okay. So if I'm going to say something like, I want the intersection of sets A and B, Well, that's the same as writing it like that. Really, it's dealer's choice. What symbol would you prefer to use? It doesn't matter. Okay, now on the other end of that is what we call the union. This is a capital U. It's the union of sets is the set containing all the elements from the two. I kind of like to think of this as a marriage of the two sets. Because I'm going to take every element in one set, every element in the second set, and I'm just going to combine it into one brand new larger set. Okay. Now, what's the key word for a union? Or. So I could say, I want all of the elements in set A or set B. Those key words are going to tell you what you want to do specifically if you're not given like union or intersection. And just like the upside down U and the upside down V can be the intersection, you can also have a capital V to help you with union. How many people remember this? It's kind of coming back to you? Kind of, sort of, good, okay. Well, there's also a couple of words that can be used to describe intersection and union. Again, it's just more vocabulary. You could also use the words conjunction, or does anybody know the other one? Disjunction, that's exactly right. Conjunction is another way to describe an intersection. Disjunction is another way to describe a union. Okay, well, this curvy E right here, that means is an element of or belongs to. So let me give you an example. If I had set A is going to be made of 4 elements. Let's just say 1, 2, 3, 4. Okay. Is it a true statement to say that 3 belongs to or is an element of set A? Yes. Okay. That's what I want to get you comfortable with. I want you to be able to read the mathematical notation and understand what it's trying to tell you. Okay. I can even write this. Would it be a true statement to say 5 belongs to set A? No. So you know, like when you have equals, you go ahead and put a slash to it. The same thing can be done here. 5 is not a member of A. 5 does not belong to A. You could also write it that way. Now, the sideways U's, this means is a proper subset of. The only difference is, it's just like when you're dealing with your inequalities. If you have a bar below that symbol, it also means or is equal to. Okay, so what we're talking about here when we say subset, we're talking about a group contained within a larger group. So let's think about the Lubbock High campus. Okay, all the students here are Lubbock High students, right? But this group that I'm seeing right in front of me, you guys, this group, third period pre-calculus, this is a subset of the entire school. Nobody else in the school belongs to third period pre-calculus right now. So we are a group contained within a larger group. So we're a subset of Lubbock High. Does that kind of make sense? Okay. Good. All right. Let's talk about some symbolic definition. Now, these definitions that I have up here for intersection and union, that's the actual verbalized definition. This is saying the exact same thing, only using symbols. These are what we call solution sets. Okay, when you write an answer like this, we refer to those as solution sets. So what's the U mean? Is that union or intersection? That's a union. So I want the union of set A and set B. So this is all values of X. And what does the colon mean? It's a 2-word phrase. Who said it? Someone said it, such that. Oh, I heard it. Who wants to take credit for it? Okay. Is it Kashal? Okay. All right. There you go. It does mean such that. So I'm going to go ahead and put an arrow pointing to the X. This is all values of X. And then this colon right here, such that. Okay. So basically, I'm going to write down all the answers that belong to my set. So I'm going to say all values of X such that, and then what follows, that's the restriction. That's going to tell me specifically what values of X are my answer or belong to my answer. Okay. So what does this mean right here? X what? X is a member of set A, or, very good, that's the union, X belongs to set B. Okay, remember that key word is going to come in there. Okay, so this one's or. This one here, what's that mean? The upside down U? That's the intersection. That's only what they have in common, which each element, each set, I should say, shares. So all x, now this vertical line segment, it also means such that. You might see in different resources, instead of a colon, you can easily replace that with just a little vertical segment, means the exact same thing. Okay. So x belongs to set A, and x belongs to set B. Okay. Questions? All right. Well, I know what you're thinking, Mr. West. That's a lot of good information, but could we see some examples? I'm glad you asked. Okay. Now, it says use set notation to go ahead and do this. Let's actually go ahead and write our answers just as sets. I'm not going to worry about writing it as the solution set we did just a moment ago. Determine whether the statement about the set is true or false. Okay, so n is the set of whole numbers greater than 12 and less than 16. So let's go ahead and write the set first. What would be the first element that belongs to n? Oh, I heard 12 and I heard 13. Why 13? There you go. It says greater than 12, not greater than or equal to. Now, what's one thing that's definitely not going to belong to my set? What kind of values? Well, definitely negative. Decimals and fractions. What word tells me that? Whole. In fact, do we remember the hierarchy of numbers? How we would classify values? Okay, let's do a quick review on that. I mean, tomorrow it's going to be our main focus, but any value that you come across is what? Starts with the R. It's real. Any value is always real. Now, the reals can be broken up into two subgroups. Rationals and irrationals. Okay, so irrational is I. Does anybody remember what letter represents the rational? Q. Okay. So what does it mean to be rational? You can put it on a what, sir? True, but any other group, you can put those values on a number line. Kasha? It has an ending? No, this is an infinite set. Okay. These are all the values that can be written in the form, what did I just write there? A fraction, such that A and B are integers, and B cannot equal what? There you go. You cannot divide by 0. Okay. So there you go. What's the first subgroup of the rationals? The integers. And what is that? What letter represents that? Z. Then what's the next subgroup? Or subset, I should say. Oh, not n. One more. Whole numbers. And then we have n, which stands for the natural numbers. Okay, now if something is labeled as irrational, there are no subgroups or subsets of that. You can't go any further. So if you kind of think about, this hierarchy, way back in the day when you guys were in, say, kindergarten, you started learning about just your normal counting numbers. You started to associate numbers of objects with values. So 1, 2, 3, etc. And then as you got older, more ideas were introduced to you. In fact, the whole numbers and the natural numbers are virtually identical, but the whole numbers have what extra element? 0. See, all the naturals are contained within the wholes. So the natural is a subset of the wholes. The wholes, in turn, are a subset of the integers. So they have 0, the positive counting numbers, and they're what? They're negatives. They're opposites. And then you got older, we started looking at fractions and decimals and all good portional values. Okay? You guys remember that? Because that's going to be the second part of the quiz. Okay, but let's go ahead and move past that. In fact, what are the other elements that belong to n? 14 and 15. Okay. So 13, 14, 15. So is it a true or false statement to say that 15 belongs to set n? That's true. Yeah, see him right here. There he is. Okay. What about, and I'm going to give it a few seconds before I go ahead and take care of the roll, but V is a set of vowels. So what elements are going to make up set V? A, E, I, O, U. Okay. So is it a true statement to say that G belongs to V? No, that's false. Okay. What about M is the set of months that begin with J? Okay. Now, is it true to say April belongs to set M? Yeah, we're not saying Japril. Okay, doesn't make sense. But this is one of those examples, probably don't need to go ahead and write out the set. Would anybody like me to do that? How many elements would be there? Oh, not 2, 3. Because you got January, June, July. There we go. So April does not belong to M. That's also another false statement. What about X is the set of numbers on a die? So does 4 belong to set X? Yes, that's true. That's a true statement. Does anybody want me to write out set X? Oh, a die is, like you say, a pair of dice. That's a 6-sided figure of the cube. Okay. So here, 1, 2, 3, 4, 5, 6. There we go. Okay. All right. Question so far? Easy. Easy. Good, 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 good. Okay. Well, now let's move a little further. Let's talk about Venn diagrams, which is a way to visualize sets that you may be working with. So it says if every element of set B is also contained in set A, well, we call that a subset of A. We'll talk about it a little more down here. And it's written using that notation. Now, the universal set U, okay, we use that style letter to represent our rectangle, is the set of all possible elements for a situation. And actually, this is a typo here. That should be a period and then capitalized. Otherwise, it just doesn't make sense. All other sets in this situation are subsets of the universal set. In the Venn diagram, sets are represented by shapes, usually circles or ovals. So you're going to go ahead and draw a rectangle. That is your universe. That contains every element of all the sets you're talking about. But inside, you're going to have, different looking Venn diagrams depending on what the relationship is. In fact, a lot of times, you'll probably end up, with something like that. Maybe just a little overlap, okay, but they're going to vary. Okay. In fact, how many people will remember working with Venn diagrams? Oh, so a lot of people. So we've been there, done that? Been there, done that. See? Alex gets it. He doesn't want it, but he gets it. Okay. All right. Let's see, where are we? Okay, so let's suppose that set A is going to be everything from 0 to 8, and B contains the elements 1, 2, 3. Well, because 1, 2, and 3 all belong to set A, well, we can make this statement right here, that B is a subset of A, right? So if I wanted to visualize that, I'm going to go ahead and draw set B, represented by this circle, completely contained by set A. Now, like I said, it is possible to go ahead and do this. I mean, if I wanted to go ahead and say A is here, and then this right here is B. Okay. Remember, B is 1, 2, 3, so I would put 1, 2, 3, but what am I going to put here? Oh. No other elements belong to set B. See, that's why it's more appropriate to put the full circle inside of the other to actually show the subset. I mean, technically, we're not wrong here, but, there's just a better way to do it. Does that make sense? Okay. Well, there's one big concept that comes along with this when we're dealing with sets. Okay. It says the set of elements in the universe that are not elements of set B is called the complement of B. And this is our notation. We use a little tick mark on that set we're referring to. Some people might actually call it prime because you might be in the habit of doing that from geometry. Like if you go ahead and reflections and things of that nature, A becomes A prime. But here we refer to it as the complement when we're talking about sets. The complement of B is going to be the shaded region. Now, I'll show it to you in just a second, but the complement of B means all the elements that are still in the universe, but not in set B. So if I were going to go ahead and visualize this, I want everything in the rectangle, the universe, but not in B. So I'm going to shade everything outside of B. As long as it doesn't belong to B but belongs to the universe, that's its complement. Okay, well, let's look at an example. Okay, let's actually go ahead and put this into play. The universe is everything from 0 to 9. And then we have sets A, B, C, D, and E. Okay, Now, this is actually what a large portion of your quiz is going to look like on Thursday. I'm going to give you some sets. Now, I would encourage you, if you're having trouble, to go ahead and draw yourself a Venn diagram. If you don't feel the need, then please don't worry about doing so. But let's go ahead and construct this. Let's visually see what the relationship is between the sets. Now, typically, on one of the corners, you're going to go ahead and put U for the universe, and you're going to go ahead and label how many elements belong to that universe. How many elements belong in the universe? 10, from 0 to 9, right? So I'm going to say 0, or U equals 10. The universe equals 10 elements. Now, I'm going to go ahead and kind of revisit two of the basic ideas when it comes to sets. And then I want you to start seeing the relationship, which is going to help you draw the Venn diagram. What if I asked you for this and then this? What's this first one mean? The upside down U. That's the intersection. Well, what's the intersection between two sets? What is that asking me? There you go. What elements does one have that's also in the other? What do you notice here? 5 and 7, 5 and 7. So the intersection of the two would be 5 and 7, right? Okay. Well, what does that U mean? That's the union. Remember, I referred to it as a marriage. So I'm going to take everything from the two sets. I'm going to combine it into one new larger set. But what about the elements that repeat? Would I, for example, put 1, 5, 5? No, even if it repeats, you just put it once. So what's the union? 1, 5, 7, 8. Well, I'm looking at those specifically because I want you to see a larger idea here. Do you notice anything? Like, what answer did I get for the intersection? For the intersection, I actually got set B, right? And for the union, I actually got what? Set C. What is this telling me? B is a subset of C. And I can never draw those without making them look like C's. Let's see. There, that's better. I want you to think later he said BCC. That makes no sense. Okay, so that kind of gives you an idea about how you're going to go ahead and draw your Venn diagram. Just like the previous one, you're going to have one set completely contained within another. Is everybody okay with that? Now, I want you to look at some other ideas. You've still got set A and then D and E. But within this rectangle, you have to have everything from 0 to 9. So let's take about 45 seconds to a minute, if you haven't already done so. Draw a Venn diagram that would give me this same information if I weren't given the sets, if I were just given it visually. And now, while you guys are doing that, I'm going to go ahead and tell you something real fast. One of the items you picked up today is the what? It is the homework assignment. Now, remember, this year, our grading policy changed. We are no longer taking grades on homework. I would still encourage you to do this. Why? It's going to be practice. Not only do you have a quiz Thursday over this material, but you've also got a test next Thursday, which is going to cover the same material. Also, let's say, hopefully it doesn't happen. Everybody's going to come in and just blow that quiz out of the water, but let's say there's a handful of people who fail the quiz, basically make a 79 or below. And that's not failing, but 69 or below is, our new grading policy. You can't retake until what? Until the accompanying homework assignment is done. Okay. Now, I'm always going to put them up here. You'll notice right behind John. It is John, right? But you prefer to go by what? You prefer Lane. Okay. I remember John. That's cool. Okay. Right over here on the whiteboard behind him, I'm going to list all the assignments that we have for a particular 6 weeks. So language of functions, assignment 1, due 8/21. When's that? That's Wednesday. So we have 2 days. It's going to be due on Wednesday. So when we come in, I'll give everybody the opportunity. If you have any questions on the assignment, we'll quickly look at that. Then we'll go ahead, pass them up, and then we'll move on with the next lesson. Okay. So that right there is going to list for an entire 6 weeks. In fact, when the second 6 weeks starts, I'm going to erase all those and start over with that first assignment of the second 6 weeks. So you'll always be able to look up here and tell exactly when an assignment was due. Okay, so that's another way to keep track of things. All right, so let's see if we can go ahead and catch up with you folks. So we noticed that B was a subset of C. Well, what else do we notice? Both B and C are subsets of A. So I would probably draw something that looks like this. I'm going to have a larger circle, and then we'll just go ahead and label it, somewhere outside that circle. But inside of it, I'm going to have a circle here that I'm going to call C, and then inside of that, another circle that I'm going to call B. I would probably draw it in this way somehow. Okay, so that B has the elements 5 and 7. But that's contained in C. Well, what are the other elements I'm going to write here in this little crescent section? 4 and 8? Well, remember, we're writing C. So 1 and 8. There we go. Now 1, 8, 5, and 7 already belong to A, or should be A. So now I should put 4 and 9. Is everybody okay with that? What else do I need to draw? So the two circles I draw for D and E, they don't need to be touching. They do need to overlap. There we go. So maybe something like this. Let's say this is D right here. This is E. Well, what's in D that's also in E? 3. So in this overlap, the intersection, I'm going to put the 3. So see, visually, this is telling me that while D is made up of two elements, 2 and 3, I've written it in such a way that I know 3 also belongs to E. Okay, in fact, what do I need to put here for E? 6. And am I missing something? 0. But 0 doesn't belong to a set. So as long as it's in the rectangle, it has to have every element belonging to the universe. Okay, so not everybody is going to have it looking exactly like mine, but the information is what's important. Anybody have questions on that? How many people got that right? Nice, nice. That's a lot of hands going up. Okay. Well, now let's look at our questions here. So if you want to go from the sets or our Venn diagram, state whether B is a subset of A is true or false. B is a group contained in a larger group A, so that's true. Okay. What about state whether E is a subset of D? That's false. Now there's an intersection, but the elements of E don't also belong to D, so that's false. Okay. Presumpsa? Oh, you erase that real fast. Pay no attention to the man behind the curtain. Anybody get that reference? Wizard of Oz. Very good. Very good. Okay. So, presumption, what does that tick mark mean? It does start with a C. Complement. There we go. So I want to find the complement of A. What does that mean? There you go. What elements belong to this universe but do not belong to set A? So if I'm going to go ahead and shade it, if you want to look at it visually, I'm going to shade everything outside of set A. So what elements are outside of set A? There you go. 0, 2, 3, 6. That's what the complement means. Everything still contained within the rectangle, your universe, but not in that set. Okay, well, what about the complement of D? Michael, can you help me with that one? Sure, or you could just tell me what would be omitted. Okay. Is he right? That's perfect. In fact, you'll notice he listed everything except what? 2 and 3, the elements that belong to D itself. Okay. Perfect, perfect, perfect. Now, you probably already noticed what I erased here. I forgot to erase it during a second period. That'll happen occasionally. But if I were to take a set and create a union with its complement. So think about it. I want every element in the set to combine with every element not in the set. So what's that going to give me to tell you? The U. It's going to give me the universe. And let's see if I can draw a U, because I don't want to go ahead and just put U, because I don't want you to think that later when you're looking at it that it's the union. That's not correct. It's the universe, everything together. Does that make sense? Okay. These are some ideas that, they really make sense, but maybe you didn't realize since, we're talking about it. What if I wanted to take the intersection of a set and its complement? What's in a set and outside of that set? What's that, William? Nothing. Okay. So what I typically like to do is write a little zero with a slash, kind of like the no solution symbol. But we actually refer to that under specific names. Okay. Typically it's called disjoint. So if you see a Venn diagram where two sets are not interacting at all, no overlap, anything, that's what we call disjoint. But what's the intersection of them? We say that's the empty or the null set. We say that's the empty or the null set. Okay. All right, well, let's go ahead and try another problem here. The universe is going to contain everything from 1 to 8. R is 2, 4, 6. S is 4, 5, 6, 7. And set T has one element, 1. Okay, so what I want you to do is go ahead and draw a Venn diagram that represents these sets. Okay, give you about 45 seconds to a minute, at the end of which I will have somebody come on up and draw what they had on their paper. I know that, coming up here and drawing that might sound a bit sketchy. Might sound a bit sketchy. Yeah, it's good. It's good. Do-do-do-do. Okay, so who believes they have a Venn diagram that can represent what's happening here? Okay. All right, well, is it, want to say Josh? No, well, you're brand new today, so you got to give me a pass on that one. Hold on. Philip. Okay, there we go. John, Philip, I was close. Okay. No, but no one's willing to give me that. Okay, Philip, would you come on up and show me what you drew? Philip is very happy to be here today. Here you go. Okay, so R, S, and T. Oh, there's an eraser on the pen too. Mm-hmm. There you go. Okay, so he drew overlapping circles. Okay, what do you folks think? Except the zero, he's absolutely right. Everything's perfect. That's okay, sir. Thank you very much. He just added one additional element. that wasn't there, and that's okay. All right. Now, don't forget, I'm not going to be a big stickler about this, but some teachers do want you to go ahead and list the number of elements. And how many do we have here? 8. Perfect. Perfect. Great job. Okay. How many people do have something very similar to what Philip drew? Okay. Good. 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 Well, let's take a look at some of these answers here, or expressions, I should say. So, what is 3A wanting? What does that symbol mean? I want the union. So I want to combine set R with set S. What would that be? 2, 4, 5, 6, 7. And I keep forgetting, if there is a common element, do I go ahead and write it again? Don't have to do that. Okay. All right. Well, what does the other one want? That upside down U, that's the intersection, so that's only what they share. And Bennett, what would you say there? 4 and 6. Perfect. Okay. And let's see here. Xavier, what would you say for the intersection of T and S? What's that, sir? There's nothing there. They are not related to each other in any way other than the fact they're in the same universe. So you can go ahead, put that no solution symbol, or what can we call that? Null, or the empty set. Perfectly fine. Okay. Now let me go ahead and give you another one of these. What if I want this? Try to find me the set that's represented by that expression. Okay, so just to make sure everybody's on the same page, what's that symbol mean? And that's the intersection, and the slash, the little tick mark, is the complement. So I want the intersection of set R and the complement of S. Okay. All right, and then I will call on somebody in just a moment. And again, depending on what you like, you can go ahead and do this, algebraically, kind of list it out, or visually. You can kind of shade in what you're needing on the Venn diagram. Okay, so everybody about ready? What do you think, sir? Just 2. Okay, because let's say you're going to go ahead and just list out the sets that you have here instead of looking at the Venn diagram. So R is just 2, 4, 6. 2, 4, 6. Now, what does the complement mean again? It's everything in the universe, but not in that set. So I want everything from 1 to 8, but I don't want 4, 5, 7, or 8. So what's that? 1, 2. Okay, so 1, 2, 3, and 8, right? And now the intersection, what's in R that's also in that set? It's got to be 2. Okay, so if that's a way where it's easy for you to kind of see what's happening, okay, or you could shade it. So set R, let me go ahead and do this horizontal. So R, I'm going to shade horizontally. I want to intersect that with everything outside of S complement. So everything outside of S, I'm going to go ahead and draw this right here. I did vertical lines there. Well, what am I looking for? Yeah, the overlap. Okay, and the only overlap, the mesh area I have, has got to be 2. How many people got that right? Okay, nice. Nice, nice, nice. All right, well, the only thing we have left is going to be tomorrow to talk about the hierarchy. We're going to expand on it a little bit. We'll talk about focus activity, and there we go. Okay. Now, I am going to go ahead and say this very quickly. Again, another recap. What is happening or due Wednesday? Okay, the homework. Okay, what's on Thursday? This Thursday is a quiz. Next Thursday, the 29th, is a exam. What needs to be taken care of by Friday morning, 8:05? If you want to take the retake on the prerequisite. Okay. Now, one other thing, we're not using the calculators just yet. Okay, because we haven't needed them. So I still want us to go ahead and get in the habit. Remember, when the bell rings, just kind of stay here for one quick second. Okay? I just want everybody to start getting accustomed to that. Remember, it's not a power trip. But when the calculators do come out, I need you guys to hold off for 1 second just so I can make sure that everything's good to go for the next class. Does anybody have any questions? No? Okay. Okay.